Hello, in this video I'm going to have a look at the calculator section of the 2021 exam, or test, sorry, with a specific interest in showing you how to use the calculus functions of your calculator, which I don't think I've done before now. First things first, I will go through the whole lot, but some of it's just like pretty basic and I'm not going to do it. Question 1 did not require a calculator. Question 2 hopefully does not require a calculator, rise over run to get you a half. Question 3 is not that hard, really. It's worth 2 marks, so you really do need to show some working out anyway, like this. F of x equals x to the power of 3 on 2, because it's a square root, so it becomes a 2 on the denominator, so 3 over 2, because there's a 3 there. So you get that. Derivative is that. Turn it back into that format if you want to. However, just for the sake of it, I want to show you how you can go about finding the derivative. There's a couple of ways of doing it. Menu, calculus, and then there's derivative. And then you can say it's d by d what? D by dx, that's almost always an x there. And then inside this box, you put the function. So what is it? The square root of x cubed. So control square root of x to the power of 3. And then press the arrow key to get outside the square root sign, or outside the cube and then outside the square root. So that's 2 presses there. And then plus 1, press return. And there you've got 3x squared over 2 root x cubed, which I know is different from these two things. They end up being the same. It's just the way it's formatted it effectively. But you can see there's the 3 over 2 there. There's the 3 over 2 there. It's x squared over the square root of x cubed, which effectively would give you that. It's a bit of a dodgy way of writing it, actually. I don't know something like that. I want to show you a second way, though. And it's kind of, as usual, quite useful to define a function first, particularly if you know you're going to be using it a couple of times here, like this. If I go f1 of x like so, and then I use control colon equals, so that one there, and then I write the function in, just to make it a bit quicker, I'm just going to copy and paste it, but obviously you could just type it in. Oops, what happened to my colon equals? Control colon equals. There we go. And now when I use menu, calculus, derivative, I can put in my x here, and then I can just type in f1 of x, like so. And you can see it's giving me the same answer as you would expect. And then if you needed to graph the function or anything like that, you've got the function defined already. And don't forget they are stored under where it says var, and you can see there's f1 of x there. Okay, so that's the first part done. Now for the second part, which is evaluate f dash of 2. And again, we can go straight into our calculator and we can go back to the menu and calculus. And this time we'll find the derivative at a point, because f dash of 2 means find the derivative when x equals 2. When you've got that, you can set the variable as x, and the value is 2 here, and click on OK. And it fills it all in nicely, and you've just got a box here that you need to fill in, which you can with f1 of x because you'd already defined it. It gives you the exact value, 3 root 2 on 2, but you can also go control enter and you get 2.12 in all those decimal places. Which one should you use? Well, check out the question. It says evaluate to 2 decimal places. So you should be using the approximation 2.12. Now, obviously, if you hadn't defined f1 of x, you can put the function directly in there. So I could have put square root of x cubed plus 1 inside this bracket here, and it would give me exactly the same answer. The next one is find the equation of the normal to the curve y equals x squared plus x plus 1. It's worth 3 marks. You need to do a bit of working out. So you can see I've got at x equal 0.5, y equals 1.75. So there's a point there. So how would have I done that? I probably would have gone f2 of x control colon equals x squared y f2, because I used f1 in the subsequent question. I could have just as easily have created a brand new document and used f1 of x again. So f2 of x is defined as x squared plus x plus 1, like so. and I need to know what y is, so I'm going to go f2 of 0.5, and there we go, 1.75. So done. What else does it say? I need to find the equation of the normal to the curve, so I know that means I need to work out where the gradient is. So I've done a quick calculation here. dy by dx equals 2x plus 1. Probably easier to write it, isn't it? And then at x equals a half, dy by dx equals 2. So all of that's pretty straightforward. And I don't think this is a saving of time, but again, I'll show you. I might show you a different way of getting that derivative, by the way. I can go into this button here, and this button has a lot of commonly used functions, and you can see this one here is d by d something to something. So if I use that, it's the same as going through the menus. So d by dx, and again, I've got f2 of x, and it gives me my derivative, 2x plus 1, and I can go menu, calculus, derivative at a point, and put it in here because I know that it was at x equals 0.5, and go f2 of x, and there's the value 2 there. Is that worth it rather than you just doing it by hand in your head? But anyway, you know what I mean. Probably not. Probably easier to do it this, but if you're really struggling, or if you've got time and you're going through it and thinking, oh, better confirm all this is right, you can definitely do it. You could have missed this step, of course, as well, and just gone straight to the derivative at a particular point. So then I've got the normal defined as this, y equals negative a half x plus 2. Okay, now it says here, I don't know why it's not in the answers here actually, but with 3 marks, it's anyway. It says find the other x coordinate where the normal intercepts the graph again. So for some reason that was maybe that was taken out of the questions. It's only worth 3 marks. But you've got your equation here of the normal. You have to find the other x coordinates. So if you are asked that, you can go control plus page, add a graph, and I can turn on f2 of x like so. So I press the, I think it's the left arrow. It's either the left or the right. I try the right arrow. Yeah, and that turns on that function there. And then I can go down to f3 of x, and I can make it basically the normal that we worked out. So it's minus 0.5x plus 2, return. There's x equals a half is that one there by the looks of it. So this must be the other one. So now I can go to menu, analyze graph, intersection, go to the left here, click, and then go to the right, and you can see the intersection is given to me, minus 2, 3. So minus 2 is the other x coordinate where the normal intercepts the graph again. If I keep on going to the next one, just to confirm, yeah, I've got x equals a half, 1,1.75. So that's how you can use your calculator to work out that other x coordinate if you are asked. There we go. Okay, next question. Use calculus to find the stationary points. Now, again, you have to show some calculus here. You could go back to your, I might even start a new one so it's all nice and fresh. So new document, don't save the old one, add a calculator, and I can go straight into defining again. So I can go f1 of x is defined as x cubed on 3, so x to the power of 3 arrow divided by 3. Again, you'd have to be asking yourself, wouldn't it be fast just to do it by hand? Answer, reckon, minus 5x plus 1. Boom, that's it. Use calculus to find the stationary points of the function. So now I can go, I'll show you something else you can do too. I can create a new function and make it the gradient function. I might even call it g of x. G of x, g for gradient, control equals to me is defined as, and now I can go the derivative with respect to x of f1 of x. So g of x is now the derivative. It's the gradient function. So if I go g of x squared minus 4x minus 5. Hello. But I can also work out the state. This is, again, more easily done by hand, but I'm just showing you what's possible. I can also use the solve function by typing in solve or going menu, algebra, solve. And I can say I want the gradient function to be solved for x when the gradient function is set equal to 0, which is what a stationary point is when the gradient is equal to 0. Solve for x, and I've got x equals -1, x equals 5. Great. Well, what about the y? What about the y coordinates? Well, I can go back to my original function, which is f1 of x, and I can go f1 of 5. Oh, -1. I'll do it in order. f1 of -1. There's the y coordinate there, 11/3, which would be 3.6 recurring as I've got there. I can also go f1 of 5. And I've got -97/3, which is -32.3 recurring. That's that answer there. So once you've got the functions set up, being able to use them over and over again, that's when you can save a lot of time. It says describe with justification the nature of the stationary points. Again, now that you've got it all set up, you can do this really easily. So you can see that I've got my stationary point -1 here, or my x-coordinate at least, and my stationary point of 5 here. And I know they're zeros, so I just need to check these. And it is worth checking, guys. It's so easy when you've got a calculator. G of -2 return is 7. It's positive. G of 0 return is -5. Negative. G of 6 is 7. It's positive again. Positive, 0, minimum, down, 0, up, local max, local min, done. Okay, so you can pretty quickly get this. And again, you can sort of fake it and put these things in based upon what you think you know about it. But the bottom line is, if you've stuffed up somewhere, it's really good to know that if you do it on your calculator and you can see how fast it is, you can quickly create this table and make sure that this table confirms what you thought it was going to be. And if it doesn't, then you know you've made a mistake somewhere. All very beneficial. Sketch the graph of the function, clearly show the intercepts. Well, we've got a whole bunch of things already here. In part 1, we worked at the stationary points. We know whether a maximum or a minimum, but we don't have these values here, right? It says clearly show all intercepts, and I don't want to work them out by hand. It's only worth 3 marks. So what am I going to do? And you can see I've just got a mark for shape, mark for intercepts, mark for turning points. So you already know the turning points, so that's fine. But what about the rest of the information? Well, that's when you can go to your old pal, control, plus page, add a graph, and we go up to f1 of x, the one that we'd already defined, press the right arrow, and there's our graph there. I can zoom out a bit. I can see that I need to go up. I know my turning point is 3.67. It goes down to -32. So I'm going to go to menu, window zoom, window settings, always more powerful. I'll leave it at -10 to 10. In fact, I've got my axes here, so that's probably a good guide for me to use actually. So I'll go minimum of -40, maximum of 10, click on OK, click out the box out, and there's my graph. And I can use my usual things to work out all the different points here. I can either trace the graph or I can use analyze graph. Boom, boom, -2.05. And keep on dragging across until it changes. 0.187. And across we go again. Keep going. No, it doesn't want to click there for me. So I'll go it again. Menu, analyze graph, 0, click here and there, and 7.86, 0. And you can see 1, 2, and the other one I had there before. They all showed up. The y-intercept, you could trace graph to work it out, but you know enough about graphs to know that if x equals 0, that's gone, that's gone, that's gone, and it's just going to be 1. So that's pretty easy to graph. These two you already worked out, but of course you could, if you didn't know, if you wanted to confirm, you could go to analyze graph, work out maximum, boom, boom. I'm doing this pretty quickly because we have done this before. There's -1, 3.67, and menu, analyze graph, minimum, boom, boom. There's the 5 and the -32.3. There it is there as well. So it's a matter of copying that graph down with all the critical points and you are GTG. Okay, next one. What is your object's initial distance away? How I'm just doing a quick scan of the question. This is what you should do as well. How much is it worth involving your calculator? What have I got? I've got to calculate something here with S. Got to calculate something else with S here. Got to work out an average, which will mean calculations of S again. And then I've got this instantaneous velocity. Yeah, it's definitely worth defining a function. That's all I have to do in this question. So again, I'll just create a new document, probably faster than trying to muck around with stuff. No, I won't save it. Add a calculator. And the first thing I'm going to do is I'm going to define S of t as, you can use S of x, it's no drama, but I'm just going to do it according to this. But instead of just saying S, I'm going to say S of t is equal to 0.2 t squared plus t plus 16. Done, defined. Under my vars here, you can see I've got a function f that's defined as being called by using S. What's the object's initial distance away from the fixed point? It's just worth 1 mark. So I know initial distance means no time has passed, so I just got to set t equal to 0. Again, probably easier to do it by hand, but I can confirm by going S of 0, 16. Done. How far is it after 2 seconds? It's only worth 1 mark. I don't even need to do this line really. I can probably just go straight to the answer. On my calculator, I go S of 2, return 18.8. Done. See how fast that is? Less than a minute, less than one minute's worth of, it's less than 1 minute to do for 1 mark, so you're already ahead. Average velocity, I know I need to go 2 seconds minus 1 second, so 2 seconds minus 0 seconds, and you can see it's 2 minus 0 here. So I can do all this in my calculator. I can even use S of, these are just using the answers from A and B, so I can just plug it into my calculator. But you can, if you want to, go S of 2 minus S of, no, you know what, I'll just show you slightly differently. I can go into here and set up a fraction, and then I can go S of 2 minus S of 0, okay, and then on the bottom I can go 2 minus 1, so 2 minus 0, sorry, press return, I've got 1.4. I've got 1.09 here, so either I've stuffed up here or I've stuffed up here, I'm not too sure, might be stuff up somewhere, but that's basically it. Next one, determine the actual time that the instantaneous velocity is the same as the average velocity. So I'm assuming that this is the stuff up here, unless I've stuffed up here, which I don't think I have. So I'm going to go with this being right and this being wrong. So I'm going to use my 1.4 value here. So you can see that I've got here is, it's worth 2 marks, so I've done a bit of a setup. So I've worked out the velocity as being the derivative of this one here. Again, I would do it by hand. I think it's pretty straightforward, but I can also go into here, for example, and say, please give me the derivative with respect to d of S of t. Press return, and it gives me 0.4t plus 1. That's done. If you couldn't do it by hand here, you could certainly do it by calculator here. It says, and then I have to set it equal to 1.09 and solve it. So what I really should have done is I should have gone the gradient, let's call it V for velocity. The velocity is set equal to, and I'll just cheat and copy it. That's what I should have done in the first place. So that is defined as being the derivative of S of t. Done. And then I can just go solve V of t equals 1.09 with respect to t, close bracket, and it gives me 0.225, which is, I just copied this one, 1.09. I should have done solve V of t equals the value I got up here, 1.4. But anyway, you get the idea. That's the process. You can use your calculator quite powerfully to power your way through these. Now, you can only do that with practice, but the more you can power through, the better. Question, this has been a bit of a long video. It's now up to 20 minutes almost, but I just want to quickly see if there's anything else I can do. Question 7a, we've been through optimization in class, and because the video is going long enough, I don't think I'll go through this problem with you, but ultimately you need to do all this by hand. The next bit is use calculus to determine the dimensions of the prism so that the volume is a maximum. 99.9% of the time, if it doesn't ask you to justify, see how I've scribbled that out because it didn't come into the final problem, final test. If it doesn't tell you to show it's a justification, you can presume it is pretty much. But anyway, use calculus to determine. So let me start off a brand new document. So I'm going to add a calculator again to determine the prism, or to show that the prism volume is a maximum. So we can do it by hand. It's not too hard. We've got v equals 50x squared minus 6x cubed. Even if you couldn't do this, don't stop. Go back and do this. 50x squared minus 6x cubed. So I can just find the derivative of that by hand. But just in case we didn't want to, I can go v of x is equal to 50x squared minus 6x cubed. You know what? I'm going to use f1 of x because I know, looking further, I have to graph it at some stage. And to graph it, you need to use f1, f2, f3. So f of 1 of x equals, colon equals 50x squared minus 6x cubed. So it says done. Yes, I've now defined it. I can now say, if I want to say the gradient of f1 of x is defined as the derivative. So menu, calculus. Remember, there's a couple of ways you can do this. I'm just changing the different ways. Derivative with respect to x of f1 of x. And now I can just say, what is g of x then? It's 100x minus 18x squared. And there it is there as well. Again, we would expect that you can do it. And you can see here in the instructions, I've now set it equal to 0, and then I've solved it. So I can literally go to my calculator here and go solve g of x is equal to 0. Oops, what did I forget? The comma x, didn't I? And that gets x equals 0 or x equals 50 over 9. So you can see here I've got x equals 0, which is not possible because it would have 0 dimensions. You know, one of the dimensions would have been 0. So therefore x equals 50 over 9. So it's really important that you do actually rule out the ones that are not possible, like if x is negative or something like that. Okay, having done that, x equals 50 over 9, you can see now I had to work out the other dimensions. One of the dimensions was 2x, the other one was h equals 25 minus 3x. So it's a matter of using your calculator to solve those as well. So you have to do a little bit of work here, and then you can solve it for yourself. Okay, find the maximum volume. Now that I've got a value, 50 over 9, so nice, I can just go f1 of 50 over 9 is that, which is exact. Probably better to use a decimal in this case, 514.403, and there's the answer there. Okay, so having done a little bit of setup to start with, look at all that usage that you can, quick usage you can make of all the stuff you need to figure out. So good. And then it comes back to sketch a graph of the function for an appropriate domain. So then you can go Control plus Page, grab that graph up, use your arrow key to get up to the first function which we defined, press the right arrow to tick it. There it is there. We need to get it for a decent domain. We know there's a maximum of 514 because that's what we worked out. So I'm going to go to Menu, Window Zoom, Window Settings. I don't need the negatives, so I'll just leave a little bit of negative here, and I'll go as far as 10, I suppose. Sounds reasonable to me. And I don't need a negative y, so I'll just leave that as minus 10, because I'm going into the hundreds. Make the maximum 550, something like that. Click on OK. Click out, get that box out, and see, you can see it's a beautiful graph. So it really is framed nicely by you using the window settings rather than using the click zoom thing. And again, you can do the usual. You know that's 0, 0. We can see that, and we didn't work that out, but we can go to Menu, Analyze Graph, zeros, click left of the 0, and then to the right of the 0. You've got 8.33. That's the most important bit. This bit here, don't be thrown off by it. Remember, this is a 0, so that means y equals, for the x-intercepts are when y equals 0. I know that looks weird. It's just a dodgy bit of the calculator there. So you can treat that as 0. If you want to know what that number means, you can ask me and I'll tell you, but that's the main thing. You already know the turning point, so you don't need to work that out. But again, you can go to Menu, Analyze Graph Maximum, click to the left, click to the right. There it is there, 5.6, 56, and 514, which you can write in. It says for an appropriate domain, so don't forget you should not be graphing this bit or the bit underneath. You should be making a definite stop there should have had a round circle there really, because you can't really have 0. So round circle there, up it goes, down it goes, just copying basically what this looks like as best you can. Mine's not a very good picture. And then putting out an open circle here to say it can go down to that point but not be that point. Critical points, appropriate domain, done. Sometimes you might see people shading out this part, shade, 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 and that's fine to do as well. But the most important thing is that the line cannot go beyond this and cannot go beyond that and have all the other critical points in. Okay, so that was a fairly long video at 25 minutes. I apologise for its length, but nothing else I can do about it. So the important things are, just to quickly summarise in terms of functions. Number 1, use your function defines. That's control equals there, colon equals there. Define your functions, define your gradients. Use menu calculus derivative to find a derivative. Use derivative at a point to find a derivative at a specific point if you need to. Personally though, if you need to find a derivative of a point, if you've defined the function here, if you've defined the gradient function here, you can always find the gradient at a particular point by going g of that particular point. Or if you're trying to find the gradient, if you're trying to find the x coordinate at a particular gradient, let's just say the gradient is equal to 2, then you can always use the solve function there. If you can get through this calculator usage, if you can get through this calculator usage, sorry, I'll say that again. Wow, sorry guys. If you can practice your calculator usage until you're really fluent on it, you'll be able to speed through the calculator section of your exam. You really will. You'll be able to, A, confirm your answers. So important in an exam that you can do that. And B, you can shortcut some of your answers where it's only worth a couple of marks so that you can quickly write things down. So instead of this taking you 10 minutes to do by hand, you can literally do it under 2 minutes for what you need to do. It's well worth practicing your GDC. Okay, I'll get off my soapbox and stop this video.